So let's take a look at these cases. The first one is dealing with ingesting operational data. Simply put, we want to allow an organization to upload operational data into some system that will construct summaries and analysis of that data and deliver those results to some interested community, right? If you want to draw a picture of it, an organization of some sort regularly produces operational data in their internal systems. That data needs to be injected into some other environment which can validate, enrich, and analyze that data, and then present it back to some interested user group or constituency. In the actual use case that I'm going to show you, the organization that's producing the data or the organizations that are producing the data are public schools, but it could be any enterprise really. But in this case, it's public schools. So the operational data is things like enrollment, class schedules, contact information. Attendance is probably the most dynamic data that we're dealing with in this example, as it changes multiple times a day and it needs to be ingested. The ingest process needs to handle that velocity. But all that data is summarized and analyzed and then made available. The interested community, the users, the target of all this could be teachers, administrators, or parents, anyone that needs to know anything about the daily operations of a particular school. Right. Fairly easy to understand case where you need to ingest data from your operational systems into some other system that can add value. It gets more interesting though when you need to design your system so that it can support multiple schools with the same ingest process, right? These individual schools may provide data in different formats, or only provide some subset of the data, or provide it at a different cadence. We want to design an ingest job that can handle all of these situations and easily be configured to handle any variances that might occur, and easy to add new schools, right? That's probably the most important piece, right? The design needs to be able to scale up so we can add support for ingesting data from more schools without necessarily adding people to do that process. Right? We want to be able to handle increased volume simply by tuning or configuring a single ingest job. Right? If we think about the steps of the ingest process in this case, this is what we're faced with, right? We need to monitor a primary source for incoming files. In this case, the schools all push data up to an FTP site. They each have a private folder, and multiple times a day, they push data into their folder on the FTP site. And that's where the process begins. There are some cases though where the school needs to occasionally send some out-of-band data. So in addition to monitoring the FTP site, this ingest process also needs to monitor an email box to make sure they're not sending some files in some out-of-band way. And we want to take the files that might come in via email and simply put them on the FTP so that they can join the main, they can be sort of routed through the main ingest job. So that's detecting the arrival, the ingest process itself. Multiple steps here. You see, we got to pull those files off of the FTP site. Sometimes they're zipped, so we need to unzip them. We need to check a manifest, make sure that this particular school sent us the correct number and type of file. We want to do some quick quality assessments of the data. Make sure it's not, they didn't send us the same file twice. They didn't send us the same file they sent us an hour ago, or they didn't send us empty files, or files with dates in the future, which shouldn't be possible, right? So we can do some quick quality assessments as part of the ingest. Some of the schools have special rules that we need to apply on a school-by-school basis, transforming the data before we can finally load it into our target system, and then finally log the whole process from detecting the files on the FTP all the way through loading the target. We want to create a rich log of the entire ingest process, right? So a lot of steps in this ingest, right? Take this bullet list and turn it on its side, and it starts to look, it's a flow chart now, but it starts to look like a data pipeline, right? These are the same steps. Get the files from the FTP, confirm they're the ones that we want, perform our quality checks. Starts to actually look like an ingest pipeline. All right, that's a natural way to sort of translate the visualization. And we'll take that a step further, because as it starts to look like a data pipeline, then we can switch over and see what a pipeline might look like in CloverDX. Right, so here is a screenshot from CloverDX Designer. This is our part of our platform. It's the desktop application. The panels around the edges provide information about, which pipe I'm working on, what are the components of that pipeline, what other components do I want to add that can be added from this palette over here on the right. There's logs that tell you about any errors that occur as you do your design. So this is a very rich desktop environment for designing data pipelines. The real target, though, is the pipeline itself, and you can see that here in the center. And it looks very much like that flow chart, right? When we zoom into this bit in the center, which is actually the, the actual ingest pipeline, blow that up a little bit, and you can see the logic, right? Where we've got a component that checks the FTP for incoming files, skips files that are not interesting to us, deduplicate where necessary, and then process, perform the ingest and create a log, right? So we see that, we can see how the business pipeline, design of the pipeline sort of translates into a CloverDX data ingest pipeline. And I'm going to show you this live in a few minutes, but a couple more slides first before we get through this. These are our components, right, on the flow chart, but the edges, the arrows in between them, which we call edges, they contain some very useful information for managing the ingestion process, right? Here, for example, that arrow, we call it an edge, contains information about the files that we detected on the FTP, their names, when they arrived, what their size was, like that. Whereas down here, the edge between the components is giving us information about how the ingest process worked, how long, when it started, how long it took, if there were any error messages. So these edges, the connectors between the steps of this process, they're not carrying domain data, data about attendance or classes or schedules. It's containing data about the state of the ingest process. Data that is necessary for good logging of this process in case we need to debug or audit that in the future. So very strong capability to not only visually design these pipelines for ingest, but to collect very useful information about managing those ingest pipelines in production, right? Now, remember, I said, here's our base pipeline, right? Get the files from the FTP and run it through the pipeline before you load to the target and create the log. But there was this second sort of pre-processing step that we needed to be able to handle as part of the ingest as well, which is the files might not always start from FTP. Sometimes, occasionally they'll come in an email box. So we need to monitor an email box for certain emails. When we find them, grab the attachments off of those and sort of mainline them back into our primary ingest pipeline, right? So this is sort of an optional pre-processing step to our entire ingest pipeline. Well, our CloverDX platform can handle that as well, right? Here, another screenshot of our design environment, only now I'm designing a different pipeline here. This is a segment of this sort of pre-processing segment. Again, let me jump into the part that's interesting. We have a component that will read email, and we'll look for an email that has a particular subject and also has attached files. If it matches those criteria, we're going to grab the attachment off of the email and push it to the correct folder on the FTP, and then send an email back saying, yes, we did get your out of band data. right? So we are not only designing an ingest process that handles the main core, we're also handling this pre-processing stage as well. Good. And then we get into the meat of things. You should be starting to see the familiarity. These are segments of a CloverDX pipeline as built in our designer, but this is the actual ingest. 6 steps in that flow chart at the beginning, 6 steps in our stages here, each of them represented by a segment of a pipeline, right? Grabbing the files off the FTP site here, moving them down into an area where we can operate on them locally, unzipping them. This stage here runs through an unzip process. Some schools send us the files zipped. Some of them just put the files up straight on the FTP in unzipped form. So we need to check if there's any unzip necessary. Then school by school, we need to check. Some schools are only going to send us 1 file. Some schools may send us 4, 5, 6 files. We have that in a configuration file. So we just compare what was sent to us on the FTP versus what we expected to get, and make sure that all the files that we need are present to actually perform the ingest. If not, we'll stop it, we'll fail, and we will notify the client that, there's some missing files in this iteration. Step 4, let's do that sanity test, right? Let's take those incoming files and run them through some data quality checks. Is this file empty? Is it of the right format? Are there too many null values in key fields? Are there dates in the future? Never should be any dates in the future in these files, because primarily attendance files. So we can do some things to identify suspect data and prevent it from being ingested into the system, and instead notify the school that the ingest failed. I mentioned earlier that some of the schools, have additional transformations that might need to be done to shape the data as part of the ingest, maybe combining 2 files together, or splitting up a field apart into some component pieces, right? There's some school by school transformations that can be injected into this ingest. So a general pipeline with 6 steps, but step 5 here has got some school specific customizations that can be added without disrupting the nature of the overall generic pipeline. Finally, when those steps are done, we take the files that we've validated and perhaps transformed, and we push them down into the next stage of the system. In this case, we're copying them to S3 and then dumping them and then making an API call to an analysis engine that can begin the analysis of this hour's attendance, right? So end-to-end orchestration of all of the steps of this particular data ingest, right? These are pictures, all right? I've showed you a lot of screenshots here. Let's take a look actually at seeing some of this a little closer to real. And I want to show you the design piece and the server piece. So drop the slides for a moment and bring up my designer first. CloverDX designer, I showed you a screenshot of this a moment ago, and here's the master data pipeline, right? I can move these things around. I can bring a palette in here if I need to add a new component, a new reader, or maybe I need to read from a flat file. Very easy to add that and wire it in. Nice, rich graphical environment for running these things, right? I've actually done a test run recently, right before our meeting started. I mashed this button and did a trial run of the pipeline so I could test it and make sure it's working the way I wanted it to work. You can see in my console, I got an indication that it did work correctly. It took 23 seconds to run. This was, probably about an hour ago when I ran it. And I can see the data as it flows through. There's numbers here on these edges that contain the record counts, and I can actually view the status too. So if I click here, I can see the check of the FTP site found all of these files. This is their sizes and the dates they appeared. All interesting information for logging our process. Boil it down to the 3 core files that I'm wanting and make sure that these are 3 clients that I do want to process. And then when the process is completed, I've got some additional information, the run ID, how long it took, and what its ultimate status was. If there are errors that occurred, they would appear here as well. So I can inspect the data in my design environment as I build this pipeline and test it and make sure it's actually performing the way I want it to perform. Right? At some point, I will convince myself that I've designed my data pipeline to the point where it is logically correct and it's behaving the way I wanted it to behave. And I'm ready to leave the design environment and move this project into production so that it can run automatically and unattended. Now, my project name, showed here in the upper left, called Webinar Data Ingest Orchestration, right? And it's got these folders in it, and it's got these individual pipeline files in it. All of this represents this ingest process, right? So I'm going to push this entire CloverDX project out of my design environment into my automated production environment, right? That's got a different user interface. Let me show you that. And it's web-based because our production environment can run anywhere. It can run in the cloud or on-premise in your own data center. Regardless, it's going to present you a user interface, a web-based user interface, right? I can log in to my production environment. And the first thing we see is this dashboard that shows the health of my pipeline, right? This is our ingestion webinar pipeline. I can see I've had an error recently. If I click here, I know that the FTP, I can see immediately, why the FTP site was upset at me, timed out, or had some issue, right? So I have immediate alert that my pipeline is unhealthy, right? I can jump in here and investigate why it's unhealthy. If I understand it's transient or understand why, I can simply reset, and I've got my main dashboard healthy, right? We want to come into this platform and we want to see, we can have a separate box for any pipeline that we're running, and we want to see green check boxes across the board, right? Interesting tabs along the left, I'll go through very briefly. Sandboxes, just a list of all of the projects that I had eventually built in Designer, right? But now I've deployed, these are the ones that I've deployed into production. Here's the one that we're talking about. This one started in design, but now is in production. I can open it up, see that same set of files that we were talking about. If I click on one, I can actually see a picture of it, right? Exactly like it lists, exactly like it looks in the design environment, right? So I know my ingest pipeline has been promoted into production. It's available to run. Well, when is it going to run? We want to automate it. We want to run it unattended, right? And we can do a variety of things. For this ingest case, what we wanted to do was listen to an FTP site. So if I click on my event listeners, I can look at this listener. Just edit it. And this is basically saying, go off to this SFTP site, look at this directory, and when files are added to that directory, I want you to start a ingest pipeline. And the ingest pipeline, this is the name of the ingest pipeline that I want to have started anytime files arrive on this SFTP in this folder with this pattern match, right? In this case, star, I'm looking for anything. So we can listen to the data environment, whether it's a FTP site or an S3 bucket or an event queue, lots of places that the automation engine can listen to decide when it's time to run the ingest pipeline. If you don't want us to listen, we can do something simpler. We can schedule. You can schedule the ingest to run at any clock time, every Sunday at 2 a.m. You can define a schedule based on some timetable and just specify, of what second, of 1 hour, of what day, any sort of cron expression can be used to decide when to launch your ingest pipeline. Or finally, if you don't want us to listen for triggers, and you don't want to call us on a scheduled basis, you can make REST calls to any of the pipelines and say, hey, pipeline, it's time to do the ingest now, which means we can integrate with web forms or triggers from other applications. Lots of ways we can sort of on demand start the ingest. But regardless of whether you're scheduled, whether we're listening, whether we're called on demand, whichever automation mechanism that you choose for your ingest pipeline, we're going to create and maintain an execution history, a list of every execution of the pipeline, when it ran, who ran it, what parameters were sent to it, and what its ultimate status was, right? So here's our most recent run, right? I know it finished okay. I know it took 23 seconds. I know the parameters that were passed into it. I can actually, again, I have a complete log file of the execution, and I have a picture of the pipeline along with the data that flowed through it at each stage, right? And a nice execution tree. This ran for 3 different schools, and I can like look through and for Pine Tree School, I can see, for Pine Tree there, I found 4 files on the FTP, and let me just blow this up. Again, this is this could have been an execution from 2 or 3 or 4 days ago, right? We're keeping a rich execution and a visual execution history of every job, right? So whenever this ran, the last time it ran, these were the data counts that went through each section of the pipeline.